Hi, Professor. I'm Sharat Kumar. Our second project is about BICE network and cutting edge AI networks. We are from group four of a team of five people in a group: me, Hannah, Praneeth, Hemant, and Radha. In the introduction part, the project deals, like the project explains about the learning cut edge topics and implement the BICE network. Implement deep learning networks, and at the same time, like, we also discuss the some of the important definitions in the project report and in the slides as well, like they are like the sound classification and image classification and some of the important formulas in the first problem. And for second and the third question, like, we have put the codes and an execution part with the followed by an explanation. Now it's for the task one, Hannah would be explained to you clearly. Thank you, Professor.
Let us solve the following problem using Open Markov. To create a network in Open Markov, we need to clean icon create a new network. And this opens the network properties dialog. And here we just click in OK. In this problem, it will be two variables involved, COVID-19 and test. To create these variables, we need to draw. This will be COVID-19 and this will be the test. To rename, just double click here, COVID-19, it will be the first, and double click here, it will be the test. Okay, the COVID-19 has two values or states, present and absent, and the test can give two results, positive and negative. Since the first variable causally influenced to the seconds, we will draw a link, just click here to the arrow, from the COVID-19 to the test. Once we have the nodes and links, we must introduce the numerical probabilities. In the case of Bayesian network, we must introduce a conditional probability table, or CPT, for each node. The CPT of the variable COVID-19 is given by its prevalence, which, according to the statement in our example, equal to 3.4%. We need to introduce this parameter by right-clicking on the disease node, selecting Edit Probability, and here we just put 0.034, which equals 3.2% in that one corresponding cell. The value in the bottom cell changed to 0.966 because the sum of these probabilities, present and absent, must be 1. The CPT of the variable test is built by considering the sensitivity, 84.6%, is the probability of positive test result when the disease is present, and the specificity, 91.8%, is the probability of a negative test result when the disease is absent. So we need to compute these numbers. Edit probability again. So here 0.846%, and here 0.918. So Open Markov is computing and displaying the prior probabilities of value of each variable using the formula. So we just need to click OK, and we'll see the results by clicking here. So this is the presentation how Open Markov network works.
Hello, I'm Radhakrishna. Coming to task 2, which involves artificial intelligence in learning classifying the sounds using deep learning. Now, this can be a solution to many practical scenarios, such as using AI during audio clips, sessions or music sessions or using in advanced active noise cancelling purposes. And here the source code page number starts from page number 5. And these are the sample outputs here for car horn and children playing noises. And there are some basic library requirements to run the code, such as pandas, keras, matplot library, TensorFlow, and Libresa. Each library has like each attribute. This pandas offers data structures and operations for manipulating numerical tables and time series. And this keras actually acts as a interface for the TensorFlow library. And coming to Matplot library, it provides an object-oriented API for embedding plots into applications. And this TensorFlow majorly focuses on training and inference of deep neural networks. And TensorFlow is a symbolic math library based on data flow and differential programming. And the last, Libresa, is some kind of package for music and audio analysis in Python. It provides building blocks necessary to create music information and retrieval systems. Thank you.
Hello, everyone.
Yeah, coming to our part, like data set. Data set is the collection of the data, like such as the variables, height, and weight of the objective for each member of the data set. And data set is consist of the different columns or the files. In this AI development program, like we have used the data set train and algorithms to understand like the different concepts such as the neural networks to learn and produce the different results. Also, it includes the input data and the expected output. Now we go to the next slide, which is like it is a data pre-processing. It is a process like preparation of the raw data and making it suitable to the machine learning model, like which means like converting the raw data into the machine learning model. In this step, like learning is a good quality of the data and the useful information that can be extracted from the different effects. And in this, the critical that we have processed our data and feeding into our different models. Next, I'll move to the next slide. Like the urban 8K sound, like urban sound 8K, like it consists of the 8732 tagged sounds in it. Like the source file is included is the slice file name, and it is divided into the 10 categories. They are like the air conditioner, car horn, children playing, dog bargaining, drilling, engine idling, gunshot, jackjammer, siren, and street music. These are like based on the taxonomy of urban sound.
Yeah. Hello, Professor. I'm Pranit. I'm from Group 4. Yeah, coming to today's one. Yeah, I'm explaining about the task 3, adjusting the brand new deep learning programs. We gave your reference link, and then first, for each and every data type, we have 3 steps like training, validating, and testing. Here, we give each picture with pixels, random horizontal flip, and random rotation, all the different properties. And after that, we need to train and validate the image of image. After successful validations, we got mm, getting like different shapes and different colors and rotation. As we are running with a large number of images, the training process take large amount of time. To reduce that thing, we in order to reduce that thing, we divided each image into different types of batches. Here we have taken a custom batch size of 32, and we have to training process to take for both custom CNN and ResNet CNN model. After that, we're getting output like this, and we are getting each photo divided into different batches, and if different, each batch having different types of images like this, with different colors, different shape, and different rotation. And yeah, as I said, because of the here we get another output as this, and because of the large number of large number of images, it take more time. In order to reduce that, yeah, we actually time we just uh, introduce the concept of GPU. If it is present, if it is present, then we transfer the data to the GPU, and the GPU transfers evaluate for both custom CNN and resonant CNN. Yeah, and yeah, coming to the functions, we gave two functions, accuracy and image classification. Accuracy gives the how much accurate the image is, and the image classification will validates and different validates the image. And then we have a conventional block which will improve the training and validation. We have a class resonance, a CNN, which will use predefined data models. And coming to the then we got output accuracy like this. For that, in the initial we got the very less amount of accuracy. After that, we increases the one cycle epoch and everything. After that, finally we got this much accuracy, and these are the results we got after successful validations. Thank you, Professor.
Hi everyone, my name is Hemant and I'm from Group 4 in Advanced Artificial Intelligence. Today I am here to explain about our project where we have a task was given. So first of all, I want to show our project. It's basically about base networks and cutting edge AI networks. Yeah, in this my task is third one. I mean, you can see here adjusting the brand new deep learning program. So it's basically deep learning image data sets by convolutional neural networks. So it's a bit large. So let me break it into steps so you can understand very well. Um, and one thing I want to tell is thank you, Professor, because I think it's like a real-time project. So we will get hands-on experience here, how the deep learning and AI works. So let me show the process. I mean, presentation. Here is my presentation. Here, task 3. So our task is adjusting the brand new deep learning program. So from the reference, the author got 92.45. Here, our goal to modify the Python codes and increase more output. So that's our task. So first of all, when I telling about the project and the assignment, I mean the task, I said you that deep learning image data set by convolutional neural networks, right? So first of all, what is this deep learning and convolutional neural networks? So we humans can process the data with detecting their size, shape, color, and everything. So we will in daily use we will take it for granted, but in an industry or in an organization, there are many shapes, many systems, many mixtures and fixtures, something parts. So it will be difficult part for a human to do things. So he cannot find. So there will be similar size but different one. So in this process, so human brain, yeah, very curious about things. So they they developed a deep learning where it detects images and collects the data and process it and and make the different sizes or different shapes, different colors into one set. So we can easily do it. So it's called deep learning. So in this, there are uh, way more things like neural networks. In this project, we especially used convolutional neural networks, which means basically it's a deep learning process where it uses undefined data. It uses undefined data to process it and run trainings, and after that, it will bring the accurate thing. So in this, there are two CNNs. One is custom based CNN, and another one is ResNest CNN. So in this project, we are making that we are making a model of custom CNN, and we're comparing it with the actual ResNet CNN. In this, the main here in this PPT, I will explaining about the main things about what are required and what. So I told you, right? Deep learning. Deep learning is an artificial intelligence discipline in which neural networks are used to learn unsupervised from unstructured or unlabeled input. So our goal is to make more. I mean, the output should become. For that, we used Fruit 360 data sets from our reference where our professor has given us. So from that, we take data sets, and after that, processing and image data sets. So throughout the processing stage, the classification of images with convolutional neural networks must be evaluated using the PyTorch library. So here, after giving the data sets, the system will run on data sets. So it processes that. So to do this, we use, as I said, utilize Fruits 360. So there are so many images. I will show you when we go to our report. So the main has there are so many images and so many data. We must use a GPU. So you can graphical processing unit. So it's a basically it's more fast and more quicker in image and pixels validation. So that thing. So GPU usage we for more and utilized manner for utilized manner we use GPU usage due to the size of the model we utilize yeah, it's a huge thing. Auxiliary function, we use the auxiliary functions as well. So CNN definition model, yeah. So CNN is deep learning, I said, right? So in this, we use a ResNet 34 pre-trained version, and last layer is modified to fit the data set. So the last set of the data is changed to get more information. So result evaluation we are done in three formats, so we can get more accurate results: plot accuracies, plot loss functions, and plot LRS functions. So this is the these maps show how the system got processed and how it's trained and how the result is outcome. So I want to show my report here. Yeah. So first of all, main I said, right, from Kaggle 360 Fruit directory, we took data sets, which includes these number of files, courses, fruits and plants, and training these sizes. So basically data set is the collection of data where we get so a huge amount of data sets. So importing these modules, we done it with Colab or Kaggle. So Colab, we use Colab software. After that, exploring data. So after getting the data, uh, we checked that the director had equal classes in the director of training. So we have to check whether the directory and directory training has equal number of classes, so that there will be no other issues. So the validation, data sets validation and training will be done in 3 steps. You can see here. And the first training set help to train data by descending gradient. So the gradient, the color. So set validation enables you to select the best one of the training. So after test training set, there are actually the CNN process. Actually, the CNN process will take random pictures from different type. After that, they tilt the image to certain angle, so that from that it characterizes and it shows how the best result will come. So in that set validation, so we can select the training test set, assist in the accuracy identification and the final validation data set. So after that, from those huge data set, it collects the data and transfers the data. So here is the data transformation. After that, data loaders are the must, because these are the one which data is loaded. So I said, yeah, this is a huge one. So data user, we want to show the GPU usage as well. Here is a CN model training. We have developed a fit one circular function to complete the training process. It captures validation loss, measurements. So it validates each and every, in return the important for troubleshooting, which the troubleshoots the thing, it will be bring back to the system. Yeah, it's a bit it's a comparison, I mean output of the CNN model. So here we took it took around 3 hours 12 minutes for that. Results evaluation, as I said, to value result for both certain auxiliary functions must be defined. So after that, this is a graph which shows the thing. So we got 99 custom. In custom model we got 99.58 and model achieved 99.83. So I told you before, we are going to compare these custom CNN and already have static CNN, we said, reset net model accuracy. So in this way, the predictions are more than 90%. It's more than 90% accuracy. So it's possible to plot them with the assistance of the prediction image function. So basically this is our project and this is our task. And thank you everyone. Thank you, Professor.
We are coming to the last part of the conclusion, but not the least one. The task one, we have solved the problem for the COVID test by using the formula as in that, like both graphically and numerically. Coming to the task 2, based on 11 categories, our test accuracy was 83.22 and our trading test was our 8732 records. In task 3, the outcome is based on the custom model than the reset model. The best spoke model is 99.28% accurate, although it takes longer, and the recent ResNet model is 99.83% accurate. Thank you. That's all for the day.